Welcome everyone. My name is Boris Mann, and I'm here with Brooklyn Zaleka, my CTO and co-founder at Fission. Oh, hey Eugene. We're going to be running some more basically demos and overview of Everywhere Computer as we get it into people's hands and start working with it. So feel free to ask questions along the way. Just either put your hand up or Brooke, if you can help me watch the chat. We will just do a little bit of an overview today and then do a little live demo, which of course we were literally troubleshooting, up until like 7:58. We'll go from there. So the Everywhere Computer, we launched this, we announced this in Istanbul, and Fission generally has a lot of protocols and different stacks going around, and we like doing pretty unique things for everything, and we're pretty happy with Everywhere Computer as a concept because that's what we want to do. We want to make it really easy for everyone to run their own compute in lots of different ways, in a way that's open source. You can run it on your own. You can ask someone else to run it for you. You can run it offline. You can run it at the edge. You can run it in browsers, hence the word Everywhere Computer. The protocol stack that Fission has been working on for quite a few years now. The shorthand for it is identity, data, and compute. All of these were originally conceived and invented by Brooke. And typically how we work is we end up having a working group, and different members of the Fission team and external interested parties work on defining and evolving it as people build it and get used to it and give feedback on it. UCAN and our Lovable Toucan is decentralized auth. It's the one that's farthest along and is trucking along from a specification perspective onto 1.0. WinFS, Web Native File System, is our encrypted file system, public and private encrypted file system with versioning on top of designed to work very well with IPFS and content addressing. And then finally, the newest member, IPVM, the Interplanetary Virtual Machine, for portable computation, basically. So that's the protocol stack. We're putting this all together and committing to work on the Everywhere Computer, which is Fission's platform, where we're going to implement and integrate and run all of these things. What is the Everywhere Computer? So it's a network of functions and computation with payment included. Basically, you can run your own instance or rent from the network, write functions in Rust, JavaScript, Python, other things, turning them into Wasm, and then extend with any UCAN-enabled services. So, serverless doesn't work for everything. And we want to mix and match services, much like you might go to Amazon or Google or Azure and have lots of different services, but with like one kind of common system. For us, that's UCAN. Being an open protocol, you're not in any one system. You can write an adapter, and people will be able to invoke that service with UCAN. Another picture. So we'll run some nodes, we'll run some compute. Any organization could run instances of Homestar nodes and third-party compute. So that's all sorts of different kinds of things. So you might be able to plug in your Azure credentials and spin up some nodes using Azure. Maybe you have an existing fleet of computers on desktops that can run some functions in the background. And we're talking to lots of people in the Protocol Labs ecosystem, like Station, they have about 10,000 nodes on desktops that only run kind of like one functions right now. And talking to them would be interesting if they could support IPVM, and then functions might be scheduled across all of those nodes. So that's the big high level thing, the everywhere computer platform. So Fission is going to integrate all of those pieces, make that available, and run paid services of various kinds around that. While all of the pieces underneath are permissively licensed under open source. So you can mix and match these things in lots of different ways. So that next layer is Homestar. Homestar is the name of our Rust implementation, and it's focused on WebAssembly functions. So we're going for this kind of serverless mode. And that's what we're going to show and demo today. And then lastly, anyone can implement the IPVM protocol and publish interfaces that are compatible. And Brooke, really the main one there. I mean, there's a huge stack of things, but UCAN invocation for compute is the core one, right?
Yeah, so actually, if you want to just roll back to slide 2 there, I mean, it might be good to give
Sure.
a how these things are connected. Why these three? Um, so you can as an auth protocol, but as a capability system, it also functions really nicely, effectively as an RPC, and that you can chain together. So something that we're adding to UCAN, it's in the current draft spec and that we're currently implementing, taking out of this work in IPVM and bringing it back to UCAN, making it work everywhere, is our promises. So you can say, hey, when this other thing finishes, connect that up to and take that output and put it in this other function call, basically. And in this way, we can build up um, uh, graphs of computation that are also completely authorized. So it's not that you're saying like, hey, please run this thing for me. You're going out to the network, and it's always going with its authorization. So we often talk about it being like more like a movie ticket than like showing your ID, right? So you can go around with it. Wherever that goes to execute, its auth goes with it. Um, WinFS and having encrypted data. So if you need to manage things like secrets, or maybe you don't want everybody on the network to be able to see your outputs, things like that, or you need to compute over a large amount of data and you need to be able to sort it and place it in more than just a single file. WinFS connects in for that and is controlled with UCAN. So you get access to write into WinFS with UCAN. And then IPVM, it takes all the work that we've been doing with those other two and adds essentially a discovery and routing layer. So you say, hey, I would really like to, whatever, resize an image or, send an email or whatever. It will do the discovery and routing of where that needs to go. And eventually that'll also include things like how reliable is that node? Who should that go to? Who's closest? Who has this cache from a previous run? All of this stuff. Yeah. So the invocation model, we keep saying UCAN invocation. That's actually become part of the core UCAN model. We found it useful enough and an important enough improvement over the base UCAN system that it's actually just getting baked right now into UCAN as like the normal way that you should use it. So anybody now who UCAN enables a service can hook into that routing layer in IPVM and automatically be available to anybody on the IPVM network. So if you wrap your image resizing service, it automatically can become discoverable on the network.
Yeah, and some of those things that we're thinking about I'll use an existing commercial service, right? So you can't send email from a browser. A lot of the stuff that we work on is like making things work very local first. So that's an example of you're going to have to use an external service. And imagine writing a wrapper for Mailgun. And obviously that would need to be instantiated with like, okay, somebody somebody has a API key or other things like that, secrets that are put in there. But it's got a UCAN wrapper around it so that you can like, compose it with everything else. Again, much like in something like an Amazon system, where it's all in one system, where you can use the semantics as long as you pick um, services that are running on the inside of that. And we're really seeing UCAN saying, oh, you can ideally this is a common format that you can run any kind of service and delegate access to. Homestar under active development and written in Rust. And we are using the Wasm time runtime for this. And so have sort of a particular flavor of composing some Wasm functions. We are focusing on deterministic functions. So a lot of this is thinking about caching in the network, and you'll see that in the demo ish, or you'll see the concept in the demo, where you take a function and you publish it. It then has a content address that is unique, and then across the network of Homestar nodes that are running on a network, that function can be fetched and turned into tasks and workflows, all of which themselves are content addressed. And so if you have the same parameters, argument 1 = 1, argument 2 = 2, and a content address, then you only have to run that computation once, which Brooke mentioned in terms of caching. And so we're applying that on the network. And then in many cases, you may not need to recompute at all. Obviously, for very small things, not a big deal, but it's actually kind of interesting for things like parallelizing and all sorts of stuff like that, where if you're doing a batch mode, perhaps you can skip a bunch of those, or even do things like race across the network if you run lots of them. I'm going to switch over to a demo. So the getting started repo, sure, I will just click on this, is what you're going to want to clone. The docs page, oops, here, docs.everywhere.computer, and getting started is what you're going to want to run through. And I'll just go through this, read through this briefly. I have, of course, set some of this up and debugged it in the background already as of today. And we have a few fixes that we need to do around that. We are having people run, this is optimized right now for people running this on their own computer. So you're doing a developer setup, you're doing a run through, you're getting a sense of how Homestar works, and run through and see what workflows look like. So you'll have it both a node running locally on your desktop, and use our hosted control panel, which is just a web page, to control it and connect to it and see some other things around it. So the first thing to do is install IPFS. We've got a couple of links there. And if you're on Brew on Mac OS, as an example, it'll install some of these things automatically. I have IPFS desktop running. I know whenever Ugo does a demo, he just drags and drops his Wasm files directly into IPFS desktop. So that works and is fine. We have a bunch of different ways to install and get things running. There's the Mac one there, or going down to the repo and downloading or git cloning the current version of Homestar. And then I started with the getting started. That this is we're still working through what the semantics of some of these things are, but essentially you've got almost like your own personal environment or bin files in your home directory or dot files is how we're thinking about it. So you're connecting to this everywhere computer, but you've got a personal config and a personal node. So you'll be doing a few little settings in there and having your own key and other things like that. And if we flip over to getting started, there's this very simple README, a Wasm file, uh, updated 12 minutes ago. That was one of the things that we were debugging, and a settings file. And this is relatively kind of turnkey. You can poke around in there. Let's take a look at the settings file, right? Where's stuff running? Some metric nodes, some RPC nodes, a web server, where to look for a key that you're running that signs things as participating in the network. Add this, so basically you're then on your local node, regardless of you can fetch it from anywhere else. We make sure that you have it running locally. You generate a key pair. You run Homestar in the background, again, with this standardized settings file, and it sets up a little local DB. Is that SQLite that's running there, Brooke?
Yep.
So we do store stuff in a database locally, and the Homestar nodes can gossip between each other. And now I'll go ahead and access the control panel. Can everyone see that giant rotating logo?
Yes.
Yes,
Perfect.
yeah.
Perfect. So showing me a little red error message that we're debugging right now. And it basically, if you don't already have Homestar running, that you've started in a CLI in the background, if you don't have IPFS running, it'll let you know. We publish and update this to control.everywhere.computer. You can also run it locally if you want, but we're doing lots of active development, and this will be an easy way for people to get started. So I'll flip to the activity tab. So this is basically confirming that it's connected to my local node, showing that I have high load because I'm running a screen share in Zoom on my little MacBook Air, and storage and any information about like workflow runs. Although it's been up for a while, it's showing there. Flip to settings, important stuff like whether you want light or white blasting mode. We're auto creating using Fission system that we've been using for a while. You actually have a local in your browser DID that represents you, and we'll be rolling out our full account system, portable account system, that you can take a bunch of settings and other stuff with you in there. Functions. So we envision one of the things that Fission is going to do is we are going to maintain a function registry. So think of this a little bit like NPM, but for WebAssembly functions. And so these are just some sample functions that we've made available for some of our early workflow tests. The system can run basically a function identified by any content address. But obviously, if it's Brooke's handle on the internet is expeed. So imagine something like functions.everywhere.computer/expeed/my_cool_function. And underneath, that'll point to a manifest file, a content address, and have all sorts of other extra information around it. Or you can just use a content address from anywhere. So imagine that you're writing functions locally, uploading them, testing them, making them available, general loop as you're kind of hitting recompile in the background as you're coding locally, and making that available. So this will be a placeholder. This will fill out with more information over time. What we opted to do is bundle a bunch of sample workflows. Are there any people here who have worked with val.town? Anyone familiar with that? Uh,
I've seen it, but never used it.
yeah, it's a really interesting system. I'll just put a link in the chat, which basically has a really great visual interface for working with JavaScript functions. And we were really inspired by that. I'd love to actually get uh, writing JavaScript functions that can execute in everywhere computer and down the line. And so we wanted to have a visual interface that lets people understand what's going on. So this is actually a visual workflow builder that we've got going. And this is a saved one that we like bundle with the control panel. It's saying it's all ready to go. And basically this is one workflow, which inside of it has two tasks. And it's giving me an image as an input. So it'll run a crop and it'll run a blur. And those are two separate functions. We were looking at that before over here. Crop, blur, right? So what I need to do is I need to upload a random PNG. It's our friends at Newsphere. You can click on this. Ooh, pretty. And I will run it. Uh, ah, my demo both worked and didn't work because on this machine, I have already run it and it cached the results. So obviously it doesn't have to run it again because it just checks. And I used literally this image before, and it will have cropped it and it will have blurred it. There's little visual issues in there. And it's just done. And if we look at these arguments here, 10, 10, 50, 50. Obviously with a little image, okay, cool. No big deal. And it actually shows up here that it has just gone ahead and done a cached run. Yeah, exactly. So it's the upper right-hand corner where it has in fact cropped this little part of the image. uh, I should do I have a quick way of doing a PNG somewhere? I should definitely have looked for a better PNG. Oh, I know. Yeah, this one will work.
Take a screenshot of the call.
Yeah. Oh, proof of call. That's a good one too. I'll actually go ahead and actually just do sample workflow 2, and I'll upload. Did anyone else pre-order the R1? I did. Why? Because my hat is orange. I like orange. And oh, hilarious. Disclosure triangle, go away. So this will rotate and grayscale, and it hasn't been run before. So I'll go ahead and run that. Now it is actually running. So you can see that the rabbit is rotated. Boop. And now grayscale.
And perhaps worth noting as well, this visual workflow builder is not like the only interface you'll have for it. Looking at reams of JSON doesn't make for a very compelling demo. So having this makes it a little bit easier to comprehend what's happening.
Yeah. Imagine that you're calling this from a web interface, and it could be running locally in your browser. So that would be our goal, is that you have Wasm functions that can execute client side. But also could be run remotely. Sebastian asks, do we know on which Homestar node this workflow executed on? Right now, this is running literally just on my local machine right now. So we've not yet connected to a wider network. What we'll end up doing is we're in the middle of bootstrapping the network, and we'll invite people to run nodes and register. Obviously, you have a key and various visualizations. So if anyone's looked at things like the IPFS peers page in your IPFS desktop or web UI, it'll show you nodes, how many you're connected to and running all over the world. We are built on libp2p underneath, and various things like NAT punching and other things like that. So we'll run a bootstrap node initially for the everywhere computer. And we, if you're running multiple Homestar nodes in your local LAN, as an example, then you can run things on one machine. It gossips all of the results, the receipts. And so if you then go over to the other machine and run something where one of the tasks or workflows have already been run, it'll actually just show a cached run. That's what we ended up doing in our live in-person workshop. And had various people run various things and shared some images so that people were using the same image. And that showcased that ability of where a whole swarm of nodes were executing on runs together.
So there's a specific this case versus in general. In this case, it's running on Boris's node because that's the only one in his swarm. When you finish, the receipt you get back is signed by that node. And so you have its public key. So you at least always know the unique identifier of the node that ran it. And on the other side, when you're submitting to the network, you can make it completely unconstrained. And if you're running just, raw Wasm, all of the nodes can run that, as opposed to, say, sending an email, where there's very few nodes that can send an email from a certain address, right? So anybody can run that. But let's say that you want to restrict it just to, your computer and your friend's computer. So you've created a little mini cluster that way. Using you can limit down who's allowed to take your job if you want to. Of course, then you lower your availability because you're saying it's on fewer nodes rather than the wider network. But you can
limit who can run what function. If you have a function that you only want certain people to run, or for that matter, a paid function that you're like, this function's super efficient, we only want certain people to run it.
Yeah. Or you need to keep it inside your, whatever,
enterprise.
Your enterprise, machines or something like that.
Joshua, do you have a question?
Sorry, I didn't know my mic was on. No, this is super interesting, guys. Thanks.
Awesome. Let me go back to what did I have a new workflow here. Just do this one. So this is a different crop and a rotate first. I think at least one of these will be cached, but I might have done a blur before. Yeah, so this is a great example where it in fact was like, yeah, I already have a rotate 90 that's done with this image. And so the only thing it had to run was the crop. You can see this is a new workflow. This is one that I actually created. And if I go back again, this one took quite some time. If you remember when we ran it, it was sort of running as Brooke was explaining. Turns out that blur is actually an expensive function. So we'll, blur 20 is one of those things in there. So why don't we make a new workflow? And sure, we'll do blur 20 first, and then we'll add a function. And we'll grayscale it, and we'll add a function, and then we'll rotate it. Oop. That nice orange showcases this nicely. Okay, so theoretically, if our system works as intended, this blur should be cached, and then the other two do still need to run. Come on, demo gods. I don't need to save. Yes, I do need to save. I need to save. It's auto-laid it out. I want it to look funky. Do I like working with the layout? Yes. Run. Boom, boom, boom. Right? So this was great. Just showed us that this expensive blur operation had already been done and was cached. And then it went ahead and just did the grayscale and the rotate. And we can think about if we were doing this with images generally, you would start having to cache. Yeah, Sebastian, thank you. Demo gods smiled on us today. Thank you, especially. Well, thank you to the whole Fission team. Andy's been doing some stellar work on the control panel, and we just are getting to our first Homestar release automation as well. So lots more things coming here. Brooke, do you want to maybe actually talk through? So you talked about this not as the only format, but can you maybe just talk through tasks, workflows, receipts, and some of that gossiping?
Yeah, sure. So when you have a job that you want to run, so we have this workflow, we blur, grayscale, and rotate. So those are 3 invocations that are linked together using these distributed promises that I mentioned before, which sounds really fancy, but really you're taking the content address of the step that you're piping in, wrapping it in delimiters to say, hey, I want when this thing exits successfully, pipe its value in here. And then the system knows how to wire them all up together. To submit a workflow, you're basically wrapping those in a little bit of extra metadata saying, hey, this is a single workflow. Here's, in this case, you don't need any additional auth, but, if I need any additional auth, here's, all the extra information you need to actually execute those. And it gets submitted to the Homestar node, which then...
And our argument here is a single image at the beginning of it, which was submitted by a SID or content address. This could also be 1,000 images represented by a SID. Yes?
Yeah. It could be an unlimited amount of data hiding behind a content address. So content address is the hash plus a little bit of metadata on the front that represents, well, you actually don't know how much is behind it, right? So it could be, petabytes of data, or it could be a small image. It doesn't really matter. When you start getting to the really, really big data, then one of the things we're building for the system, data locality awareness, becomes more important. So you don't want to move a petabyte across the network and compute on it locally. You want to be able to push a Wasm function as close as possible, ideally onto the machine that has the petabyte, to crunch those numbers and then send them back to you. So you can imagine doing MapReduce on something, and getting just back the whatever, say the sum, right, which is just a number, but you've actually computed over some huge data set. Anyway, so that workflow description, which is in IPLD, so you can serialize that to JSON. Let's say if you want to inspect it over the network, it's going to go as CBOR, but they're interoperable. You can convert between the two. Get submitted to Homestar, which is going to do some coordination. It'll either say, "Oh yeah, I can run this for you directly," or "Hey, this is going to require a petabyte of data. I'm going to send it over there." Or "Oh, here's a node that's nearby that has some excess compute capacity. I'm going to send it to them," or maybe even break it up. So here we have 3 steps. Because these are all so quick, they would all get stuck together and run on one machine. But let's say that they were all very, very long, and maybe even there was some parallelism. The coordinator can then decide, well, I'm going to schedule this part on this machine and that part on that machine, and they can pipe the results into each other. And I'll just, make sure that everybody's staying alive in case I have to restart any of the processes. Those run. Each individual invocation generates a receipt, goes back to the coordinator node, which then signs over the whole thing. And so that's how you get your provenance of how things actually ran and who did what. The coordinator can also, depending on how certain you need to be that the function was run correctly and how much you trust the nodes, like if you're keeping it to just your enterprise or to just your you and your friends, you probably trust those results, but let's say this is just on the open network. Maybe you want some redundancy as well. It's just, to spot check, are they actually doing it correctly? And so the coordinator can also do that and like compare, did I get the same SID of this rotated rabbit at the end?
And basically, if you've got a multi-task workflow, so these individual things are tasks, the whole thing is a workflow. Let's say step 3 task fails or times out. But the previous 2 tasks have completed. So we can just run it again and wait for that 3rd task to complete or run or be successful, sort of thing, right?
Yeah, exactly. So you get sort of this course durability. So
that's the phrase is durable functions.
Yeah, so if they fail out halfway through, or go offline, or whatever the scenario, you can always restart it. You don't have to run the whole thing. You can start from, just run that last step, let's say. Additionally, and Boris mentioned this with his cache, it's not just the cache that's on this machine. If anyone that machine can talk to has this in their cache, then they can just say, hey, give me the output of that. I don't need to run that again. In the totally pure case like this, that's very, very easy. You look at the content address of the description of what you're going to run and say, is that the same as the thing that I'm trying to run? Yes. Okay, cool. Give me the outputs. And as people run those over time, you'll get more and more confirmations that it's the correct value, right?
Yeah.
When we add effects to the system, so ingesting data from, let's say from the web or somewhere else where the data can change, or sending things out, send email or post to Blue Sky or whatever the thing is, then there's a little bit more coordination. And so maybe, if you've pulled a result, you need to know, well, I'm willing to put this in cache for the next 5 minutes, but 10 days from now, maybe the value is different. I need to pull that again. So the cache changes based on what you're doing. Pure Wasm, super easy case. And most computation will be in pure Wasm. So we can then cache at least the computation stages. Hitting external services has additional caveats.
Yeah, I think a lot of the caching stuff ends up being interesting where that can be run a number of different ways, where you might be okay with a 10-minute stale calculation if it's really expensive to compute. That petabyte one is a perfect example, right? Some of these are very, very application specific, but we've given the tooling there to be like, oh yeah, it's actually going to cost a lot. And when I say cost, I mean usually compute resources one way or another. So all of this is being tracked, and we're looking at things like timeouts and how much resources a computation uses. You look at things like Amazon Lambda that's run at very large scale, and people are already doing things like deploying something in Python, loving the fact that it can just scale, and then realizing it's costing $10 million a month, and then saying, oh, let's rewrite it in Rust, classic phrase, and we'll take that down to $1 million a month. And what we see is an opportunity to use the resources of an enterprise or customer browsers or other things like that, and say like, oh, let's bring that price down even more through a mix of essentially compute offload of doing that locally in people's browsers or devices, or caching where you in fact don't need to run various computations at all. And typically in most of these systems you're being charged per convocation. So these are all building blocks and application specific. So that's the end of the live demo. Anyone can try that right now, and should be able to get it running. I'd say other than Windows, we haven't done a bunch of work there. So WSL2 is what we would recommend on there. But that should, everywhere computer. So the goal is to have it running everywhere. Please do try it out. The next thing will be writing functions, and making that available, making some templates available. You can look at the functions Wasm source code that's in the Homestar repo right now to get a sense of what that looks like. We are basically are actively asking people for things like, oh, wouldn't it be cool if there was a function that does X? So if you look in the roadmap, Danny O'Brien was like, I would love to have a sparklines function. I'm like, great, perfect idea. Let's put it in the backlog. See what's interesting. If you are a Rust developer, happy to have you get involved in the open source core Rust implementation. It's a big system. But and we're working on making all of this stuff work end to end, and have a number of people get involved. And so the function writing is the one that's going to be a much easier starting point for some of those things. And then lastly, Ryan and I are doing lots of product interviews. So we'd love to hear about your use cases. And I'll flip over to the Everywhere Computer homepage of some of those things. And that's kind of where we're at today. We'll be adding accounts. So that'll pave the way for things like saving your settings, saving your workflows, and uploading functions of your own, and having storage in the system. So those images are obviously temporarily uploaded right now, but you may want to keep some of your data sets around in different ways. Kind of fun to play around with the workflow system right now and get a sense for it. The other kind of advanced task is going in and editing your settings.toml file and putting in the IP address of another machine on your own network, or having someone else run it. We will be working on having a persistent beta network up and running. So this is a little bit it really is like running your own cloud. Obviously, some of the folks we work with work more in the blockchain space. We think of all of this as edge computing. And the type of thing that we see is that if people are a lot of patterns like this, if you look at Vercel or Netlify or Replit, really great systems that you can use, but they typically have a freemium tier. And there aren't, because these are proprietary systems, there aren't a lot of options outside of that freemium tier. And what we see here is really bring your own compute. You will always be able to run your own compute, whether you deploy and run it yourself, or you'll be able to run with friends, families, organizations, or others who are running things, or you can rent compute from the network. And that's the stage where we're at, is booting these things up and making that stuff available. Any questions on that? I will wrap up. 3 other things. Oh, yeah. Go ahead, Eugene. Feel free to unmute, ask your question if you like.
Hey guys, great presentation. Thank you. I was curious about a couple of things, but I'll just leave it to one for now. The Homestar runtime. Are you guys thinking of integrating with other schedulers like Kubernetes, for example?
No. Kind of the big part of the idea is that Kubernetes is too complex, and so we're instead of going with containerization, we're going with Wasm to help all the stuff wire together. Now you can call out into a system that uses K8s, but that's not something that we're looking to do directly in the system. If anything, there's some more modular systems out of Apache that that are like a maybe on that, but none of these really do what we need. Never mind the complexity; they actually don't totally do what we need them to do as well. So even looking at other teams like Backlia, which do some distributed scheduling with content addressed data and whatnot. They're entirely on Docker, and they're not deeply integrated with Kubernetes, right? They had to go out and they were looking at all these other scheduling systems as well. Yeah, there's just too many differences, basically.
Gotcha, that makes sense. We have time for one more question.
Yeah, absolutely.
I was also curious about the UK integration with like external services and I guess like other functions. What does that look like in terms of like registering a function? Is there like a type system or is like a spec they say like what this function can do? Is there fungibility across functions so you can like swap out different ones that do the same thing?
Yeah, great question. Because we're leaning into WebAssembly, the WebAssembly component model has interface types. So you get types on the outside of the module. They don't swap out. So if they have the same interface, you can't just be like, well, instead of this one, use that one. Like your invocation will say which ones to use, just like you're doing function calls, distributed function calls, but you're just doing function calls. um, because everything under the hood is content addressed, you know exactly what's being run, not something that's kind of like it. Like, no, I want this, blurring function, not something that happens to take an image. Doing search by interface, I think, is interesting, but we haven't done that yet. But yeah, the short answer is we're leaning pretty heavily into the WebAssembly standards. So WIT, the interface types, and the component model aren't done yet. So we're getting jump on it a little early, and those specs are moving less quickly than they used to. So they're starting to solidify. But there's external tooling that works with that. So the basic idea is you should be able to go and compile using normal WebAssembly tooling and then run that on Homestar. We'll provide tooling to make that easier, but if you wanted to, like, you should be able to take something off the shelf and just run it.
Gotcha, makes sense. Thank you. I'll look into it.
Yeah, I think the other part, the mental model that you can think of is one of the things we've observed is that not a lot of serverless functions necessarily get reused or are open source because people kind of deploy them operationally into proprietary systems. This model we think can head in a direction as WebAssembly gets more widely adopted that looks a little bit like NPM. With a couple of things, we know that there are some issues with both JavaScript and NPM. One of those things being content addressing of like, no, not just like the right version, but it's like this actually compiled bit. And to your example, like let's continue to use the blur example. We can look at NPM and there will be blur, more awesome blur. My blur is totally awesome. And infinite other functions that do those things. And then somebody will come along and be like, oh, this is actually really slow on PNGs, or this is great on JPEGs, or whatever. And kind of pick and choose for their use case. For historical reasons, many cases, like it will be interesting because, of course, all of these transactions will be logged in the network. So based on system settings or other stuff, we could see like, oh, this blur function is actually getting used a lot, or this blur function is faster. So some of that we think is going to be in like discovery of like a function marketplace and some of those other things, and one level higher up because people can also share workflows in different ways. I'm actually going to go back and talk about Kubernetes as well. It's also at a slightly different layer. So we fully see with calling out UCAN, someone may want to deploy a fleet of Docker services on Kubernetes, but that's essentially outside the system, where the interface is just then a UCAN, do the thing, give me the answer. and I had permission to do those things. There might even be a scenario where people use Kubernetes to deploy and manage a worldwide deployment of Homestar nodes. But that's like future and discovery and a bunch of other things where we want to bootstrap this up from people who have real challenges. We're exploring some things like factory control automation, who really, really want to not depend on a flaky internet connection and really, really want to make sure that their stuff runs locally. That's a very specific set of needs. If we end up having an initial customer around that who wants to work with us in using that, then we'll put time and effort into that. I was actually just reading again. I'll drop it into our Discord. Chick-fil-A, the chicken restaurant in the US, built local Kubernetes nodes in like 10,000 restaurants around the US. And it's a really, really interesting description, and also thinking about how like, oh, okay, so that's how they did it. How would this look like if we used Homestar instead for that specific use case? Does that make sense, Eugene?
Yeah, totally. And love the Chick-fil-A article. It was a great one.
Yeah. Okay, so future work and research. Let me just go over this quickly and I'll let everyone go. We are also thinking about basically payment for these things and a credit system. It's interesting when you look at things like cloud credits for various things. And where I said before is we want to preserve the opportunity for everyone to bring their own compute in different ways. So, we'll start slow. We'll bootstrap like a beta network. We'll invite everyone to set up nodes. Lots of like logging and statistics, and even just like fun badges for, Eugene ran the most blur functions on their local node or something like that. And so what does it look like to develop a billing system and a payment system that also is local first and works at the edge? Brooke's done some thinking about this over the years. Basically, we've got a lot of different actors in the network, and we have content addressable sort of like invoices. We already have computational receipts of doing things, and be able to store those things and ask people to run stuff for you. I'm flagging this under research because at the same time we'll also like, stick a Stripe interface on this and say, hey, Fission is going to provide compute and it'll be $5 a month, $50 a year for sort of like, hobby usage kind of things like that. The other big thing is thinking again about NPM, JavaScript in the browser and JavaScript on the server and Node.js. And Ugo does a bunch of this work. We are always working to make JavaScript that runs everywhere. Cloud Functions at the edge, runs in Node.js in the server and in the browser. And ideally with Wasm, we have an opportunity to do the same thing and not split these worlds. And so where we'd like to get to, and we've had quite a lot of interest in people saying, I would like this to work, is you should be able to deploy as part of a web application, a Wasm function that can just be run client side. And that fits within the IPVM framework in the same way. Obviously a hard problem, and then doing sorts of things like even detecting that you might be on a low-end Android device that doesn't have a lot of oomph for blur, and saying, oh, in this case, just farm it out and give me the answer somewhere else, and I'll pay the penalty in network latency, or upload download instead. So that'll be an active area of research. I put the W3C logo in there because that's likely related to a community group that we will start. New year, I guess it's just the end of January, so I can still say Happy New Year. So look for that. Generally, we'll let everyone know who attended one of these sessions or has signed up for our beta intake form when we do get that W3C community group up and running. There are larger groups that are interested in this, and ideally we'll convene and get that working and get this in front of browser makers early. A lot of the browser folks only focus on making stuff work in browser, but we've had some promising early discussions where people are interested. Maybe it's something like leaning into service workers that already exist, but essentially having a flag for decentralized service workers. So we're hoping we can get some folks together that are interested in that. Brooke's Edge of Tomorrow presentation that's in here really is a 10-minute talk from I guess it's almost 2 years ago now in Paris, where Brooke kind of laid out the high-level vision of our identity data compute. We're really stoked to be like standing up everywhere computer and a network of Homestar nodes. So hope you guys try it out. Let us know. The big thing will be connecting into a big network, so watch for that. But if you can start by getting things working locally for your own machine, then it should be easy enough for you to connect into the larger network. That's it from us. Any other questions? Amazing.
So, is there a group chat or dedicated to Homestar?
Yeah, absolutely. So join us in the Fission Discord, and I'll send this out in I will also send out everyone who signed up for the presentation and get you into the beta forum. So we're keeping it pretty tight knit, and so we're asking people to let us know that they're actively interested in working on it, and then we will add you to the beta forum that we have there.
Thanks.
Awesome. I will. Oh, hilarious. Our Autobot is recording, so I can't even stop recording right now. I'll have to fix that for next time. Thank you everyone for attending the first one of these. We've got a couple more scheduled. One is at an Asia Pacific friendly time. And then we'll do one with a bunch of updates in February. We can make these working sessions. A lot of this is just introing it and showing people at it. Also can schedule some time for group chats where people just like run through the getting started functions together. So happy to do that. Just ping us in the Discord or send us a note. Thank you very much, everyone, for coming today.